Okay, welcome Math 30-1 to our very first lesson. Today we're going to look at polynomial functions. So we're going to start by talking about what is a polynomial function. Wow, I got some pretty colors to work with here. So polynomial functions that you would be most familiar with, in Math 9, Math 10C, you would have done a lot of work with linear functions. Okay, so those are polynomial functions that have a degree of 1. You also would have done some work with quadratic functions in Math 20-1. So quadratic functions have a degree of 2. In Math 30-1, we are going to work with polynomial functions up to a degree of 5. And today we're going to talk a lot about terminology and just some different and similar characteristics between these polynomial functions. So to start with, this is what a polynomial function looks like. So a polynomial function generally has one or more terms. Okay, some of these terms will be constants, which means that they won't have a variable. Terms that do have a variable will have a coefficient in front. And something that you need to know about polynomial functions is all of your exponents in a polynomial functions, they are going to be whole numbers. And they're also going to be positive. So you're not going to see any fractional exponents, you're not going to see any variables as exponents or negative exponents. So a polynomial function is going to have positive exponents. Okay, the next term that we're going to talk about is end behavior. So end behavior might be a new term for you. So first of all, when we work with end behavior, a lot of times we're going to be using quadrants to describe the end behavior. So a quick little refresher, this is quadrant 1, 2, 3, and 4. Usually we'll use we will generally use Roman numerals, okay, to number our quadrants when we're working with the Cartesian plane. So with end behavior, I'm going to actually just draw you a little cubic graph over here. There's my grid. Let's use blue. Here's my cubic graph. Woo, it's going up. Okay, so my end behavior, when you're doing end behavior, you're always looking at the graph from left to right. So when I look at the left end of this graph right over here, we see that this graph is going towards quadrant 3. Okay, and if we look at the graph from left to right, the end behavior would be from quadrant 3. So I would say quadrant 3. Oh, I guess that's not very, it's kind of messy. To quadrant 1. That would be the end behavior of my graph. All right, so what is a polynomial function? Let's look at that a little more. So we're looking for functions where we see numbers, positive numbers, as exponents. So here, this is a polynomial function. All right, we have an exponent of 4, 3. We don't have any radicals on our variables. We don't have any negative fractional exponents. So this is polynomial with a degree of 4. Okay, and it has a degree of 4. Now, next, not a polynomial. The reason it's not a polynomial is you see that negative exponent. So this is actually going to be a rational graph, which we're going to look at later in this unit. It's going to have asymptotes. It's not going to behave the same way as a polynomial function when we graph it. This is a polynomial function. They're trying to trick you here. Notice how that square root on the 5 is just on the 5. So really it has a leading coefficient of root 5. But it's still a linear graph, which means it is a polynomial function. If this square root, like if I had a square root of 5x and the square root was applied to the variable, then I would no longer have a polynomial function, and that would actually be a radical. So that's something you need to watch for. Okay, over here, not a polynomial function. The reason being is we have a rational here, so we have a variable as a denominator. Over here, number 5, also not a polynomial. So I guess I'll go back to 4 and write that it's a rational graph. We know number 5 is not a polynomial because it has a variable as an exponent, so it's actually an exponential graph. It's going to have similarities to an exponential graph. Okay, so the next thing we're going to talk about is our leading coefficient. So if you were to have a negative leading coefficient, I'm going to draw on here for you. Okay, you're going to see that The odd degrees, so this has a degree of 1, degree of 3, degree of 5. Notice how the odd degrees all have the same end behavior. So all my odd polynomials have an end behavior. If you look at the left tail of the graph to the right tail of the graph, from quadrant 2 to quadrant 4. There we go. Okay, and I'm going to use another color here. Now if you look, you'll notice that, okay, I have a degree of 2 here and 4 here. So my even degree polynomials, okay, and these are all also negative leading coefficients, right, negative. Okay, they both have similar end behaviors too, from quadrant 3, oh dear, to quadrant 4. There we go. Perfect. This pretty much just summarized that for us. So when you have a positive leading coefficient, okay, and an odd degree, your end behavior is going to look something like this. Whether it's a linear, a cubic graph, a degree of 5, you're going to have an end behavior from quadrant 3 to quadrant 1. When you have a positive leading coefficient in an even degree, whether it's a quadratic graph, a degree of 4, you are going to have a polynomial function that opens up. So it's going to have a degree from, or an end behavior from quadrant 2 to quadrant 1. When you have a negative leading coefficient, your polynomial graph, when you look at it from left to right, it's going to go down with an odd degree polynomial. And your end behavior would be from quadrant 2 to 4. So I'm going to write 2 to 4. Okay, and then up here I'll write 3 to 1. And then over here this would be 2 to 1. Okay, now if you have an even degree with a leading coefficient, it's going to open down. So your end behavior would actually be from quadrant 3 to 4. There we go. This summarizes really what we talked about, odd degree polynomial. Okay, if it's positive, it's going to extend from quadrant 3 to 1. If it's negative, it'll extend from 2 to 4. Okay, with odd degree, you're always going to have at least one x-intercept. The domain of odd degrees will always be x as an element of all real numbers, and the range will be y as an element of all real numbers, unless there's a context. For example, if the y-axis represented height or the x represented time, something in that case, then you would have restrictions or to that context. Even degree polynomial functions, okay, your leading coefficient, when it's positive, your quadrants from 2 to, and this doesn't say it, but it's going to be 2 to 1, okay. When you have a negative, that end behavior will be 3 to 4. All right, so here's some questions for us to look at. First off, what would be the leading coefficient here? So I'm actually going to start with the degree. So the degree of my first equation, I'm looking for the highest exponent, and there it is. So it's going to be 4. The leading coefficient, I'm going to go leading, and then I'm just going to write C. It's going to be the number in front of whichever term has the highest exponent. So that would be this term right here. My leading coefficient is going to be -1. And then my end behavior, we could graph this, but we don't need to if we look at our rules from the last couple slides. So we know that this is an even polynomial function. We also know that it has a negative leading coefficient. So that means my graph is going to look, I'm just going to draw a quick little picture. It's going to look something like this. Well, it's going to open down. Okay. So we know that end behavior is going to be from quadrant 3 to quadrant 4. There we go. Okay, and then our next one here, here's our highest exponent. So we know we have a degree of 5 here. We know we have a leading coefficient of 2 because that is the number in front of that highest exponent. And because we have an odd degree graph with a positive leading coefficient, and I'm going to draw a little picture of what it might look like. Yeah, something like that. Okay, we're going to have the end behavior is going to go from quadrant 3 to quadrant 1. There we go. And that, we got one more slide here. So this time they gave us a picture of a graph and asked for some different terms. So first of all, my end behavior, just looking at it, those are my ends of the graph. So my end behavior is from quadrant 3 to quadrant 1. So I'm going to go quadrant 3 to 1. Okay, we know that this is an odd degree graph because of the nature of the graph. And we also know that it's going to have a positive leading coefficient because it's going upwards, right? When you look at it from left to right, it is going up. So it has to have a positive leading coefficient. Okay, so next we see this is our quadratic graph. You guys have seen these a lot before. So the end behavior, when we look at the ends of the graph from left to right, we would say the end behavior is from quadrant 3 to quadrant 4. We also know this is an even degree graph because it is that quadratic graph that we're used to. And we know it's going to have a negative leading coefficient because it's opening downwards and because of that end behavior. Those are giveaways on whether the polynomial is even or odd. So that is it for today. You guys take care. Here's some questions you can work on. Okay, if you look online, you should see an answer key on there too if you're having any difficulties.